my name is Sanju, and I will be discussing my system analysis GUI in MATLAB project. So the project overview, the task was to create a user interactive MATLAB GUI to determine the stability of a system. So what we'll be doing is we'll be taking the input values for the user system from a transfer function. So we'll have the numerator and the denominator of the transfer function and the frequency range for the system. And the GUI will generate output of these plots, the board plot, root locus, and step response, and it will provide the system information to give a clear understanding of the stability of the system. So these are the key features of the system analysis. We have the numerator here, and you input whatever values you want there, the denominator, and the frequency range. And then we have a GUI analyzer button that once we enter it, it'll analyze all the input data and will then present the output plots. It's the next key feature. So here we have three output plots, and then we have the system information box. So we have the custom board plot, the root locus, and step response, all our types of curves that demonstrate the system's stability. And the system information box contains information such as the poles, the settling time, the overshoot percentage, the peak time, and of course the most important information, which is the gain and phase margin. I designed the output panels to be all in one window. This allows the user to see every single data point together so that you have a big picture overlook so he can see every single data at the same time, including the inputs as well, so that the user can easily refer from one plot to another. So for an example, we can use the following numerator and denominator along the frequency range. Once you enter it, you could enter it like this. You could enter a bracket or not if you want to. It's up to you. The inputs will analyze it regardless of what you put with it. And this is the outputs you should get for the system. As you can see, it's all unique to the input transfer functions, and you can then analyze to see if the data is stable or not. Some challenges that I had in making this project, the custom board plot was one of the main problems, considering the fact that we were tasked with not using the MATLAB built board function. But thanks to a bunch of research through YouTube videos and MATLAB's website, I was able to solve the problem by using a logarithmic scale and implementing complex control methods. Another problem I faced a lot was in the displaying of the outputs. I'd often see that either the information in the information box or some of the axes on the plots always get cut off, or you'd occasionally see them fall out of the range. But I was able to fix this by fixing the scales and using the absolute value and angle of the result and plotted with dual axes to clearly show both characteristics. Another one was handling the invalid user inputs gracefully, because users may input incorrect values or invalid frequency range, which could cause the program to crash or return errors. A robust input validation was implemented within the analyze system callback using checklists such as the isMTB function and the length function. If valid data is detected, an error log message will be displayed to the guide to the user and will restart the GUI. So to conclude, the project delivered the MATLAB GUI that accurately analyzed system stability using user-defined transfer functions. Key features include custom board plot, root locus, gain, phase, margins, step response, and system information. The manual board plot information was enhanced understanding of frequency response, while challenges like input handling and multi-part integration was successfully resolved. The tool is effective and educational and aligns with the core control systems principles. Yeah, so thanks for watching.